Hey everyone, welcome to The Explainer. So let's just jump right into it. Have you ever popped the hood on a cutting-edge piece of tech, totally bracing yourself for an absolute labyrinth of code, only to find a perfectly organized, super simple engine? Well, today, we are opening the hood on OpenAI's lean, new Agents SDK to see exactly how it operates. And I promise you, what we find here is going to completely change how you think about building AI agents.
And that brings us to the core mystery we're unraveling today. When developers crack open the source code for the OpenAI SDK, they usually brace themselves for impact. They fully expect to see these heavy, complex, completely proprietary abstractions. They expect a massive learning curve. But instead, they find remarkably clean, incredibly simple Python code. It feels almost reminiscent of when early Java first came out, just a simple, lean design that you can grasp super quickly. So why exactly did OpenAI take this radically different approach?
Well, it all comes back to this guiding philosophy directly from OpenAI's SDK design principles. They want enough features to be worth using, but few enough primitives to make it quick to learn. They very intentionally avoided the bloated, top-heavy architectures of the past. I mean, they didn't want developers spending literally weeks learning some proprietary framework just to get a simple agent off the ground. They wanted serious power, sure, but delivered through pure simplicity.
So here is our roadmap for today's deep dive. We'll start with the Python-first approach, then we'll look at the magic of data classes, move into class versus instance variables, uncover the callable object secret, and finally, we'll step inside the agent loop. Let's get to it.
Okay, part 1. The Python-first approach. Think about legacy AI frameworks for a second, stuff like LangChain or CrewAI. They tend to give you these custom, really heavy abstractions. Like if you want to route a task or run processes in parallel, they hand you their own proprietary API to do it. You basically have to learn their specific way of doing things. But OpenAI's Agents SDK, it does the exact opposite. It leans entirely on built-in native Python language features. No new abstractions to memorize, just pure, unadulterated Python.
So here's the absolute game changer. To master this SDK, you don't actually need to learn some massive new AI paradigm. You just need to deeply understand modern Python. The core components here rely on an extensive use of type hints for strict static checking, which, as we know, is absolutely crucial for large-scale professional code bases. It leverages standard Python decorators to add functionality. And instead of forcing custom parallelization rules on you, it just uses native Python async libraries. All of this drastically reduces the boilerplate code you have to write.
Moving right along to part 2, the magic of data classes.
Now, if you aren't super familiar with it, data class is a built-in Python decorator. Think of it as basically syntactic sugar. Normally, when you build a class in Python, you have to write out all this tedious, repetitive setup code, like the init constructor, just to define your basic variables. Well, a data class automatically generates all of that boilerplate for you right behind the scenes. It keeps your code incredibly clean and focused. And if you actually peek at the OpenAI SDK source code, you're going to see these data classes everywhere. Almost every core component, whether it's representing a tool, the final output, or even the agent itself, is fundamentally just a simple, elegant data class. It strips away all that visual clutter, ensuring the source code is highly readable while remaining really strictly typed.
All right, part 3, class versus instance variables.
Let's break this down with a relatable example. Think of a class-level variable as something shared by absolutely everyone, and an instance-level variable as something totally individual to you. Imagine you're at a mosque for a congregation. The time the prayer actually starts, that is a class variable. It's universally fixed. Everybody in the building shares that exact same time. But the time displayed on your own personal wristwatch, that might be 5 minutes fast or maybe 5 minutes slow, that's your instance variable. It varies depending on the individual.
To really hammer this home, let's look at another brilliant analogy, an American class. If we write a data class for an American, the class attributes, the things shared by all instances, would be things like a national language, say English, or a national food. But the instance attributes, the purely individual traits, would be that person's specific name, their age, or their personal favorite food, like, I don't know, a pizza or a burger. The OpenAI SDK uses this exact real-world logic perfectly to manage state across its agents, just using standard static and instance variables.
That brings us to part 4, the callable object secret.
So Python has these really cool magic methods. People often call them dunder methods because of the double underscores.
And one of the most powerful ones is the call method. When you attach this magic method to a class, it actually allows an instance of that object to be executed exactly as if it were a standard function. You literally just slap parentheses next to the object, and boom, it runs.
Now, why does the OpenAI SDK actually care about callables for giving instructions to an agent? Well, normally, when you define an agent system prompt, you'd think it has to be a static string of text, right? Actually, scratch that, it doesn't just have to be a static string. By allowing instructions to be callable functions, your agent can dynamically inject context right before it runs. It could reach out and fetch today's date, pull in real-time data from a live database, or even, and this is wild, enable recursive self-improvement by updating the agent's memory dynamically based on the specific user it's interacting with. It is an incredibly elegant way to make your agent context-aware, all using standard Python.
Finally, Part 5. Inside the agent loop.
Look, if you've ever tried to build an agent manually from scratch, you know that the interaction loop with an LLM can be, honestly, incredibly tedious, especially when tool calling is involved. Think about it. You send the prompt. The LLM then pauses its reasoning because it decides it needs a tool. You then have to manually execute that tool locally on your own machine. Then you send the result back to the LLM so it can finally resume thinking. And then, eventually, you get an output. It's just this constant recursive game of API ping-pong.
But here's the beauty of the OpenAI SDK. All of that heavy, annoying orchestration, it's completely abstracted away into a single, beautifully clean class method, run_sync. This runner automatically handles that entire recursive loop for you. If the LLM needs a tool, the runner just executes it and feeds the data back automatically. It completely shields you from the manual orchestration, letting you actually focus on the fun part, what the agent should actually do.
So when you step back, the resulting elegance of the OpenAI SDK is just undeniable. It achieves this massive, incredible power simply by combining basic native Python features. Your agent is just a clean, readable data class. Your system instructions leverage dynamic callables to grab real-time context, and all that messy execution is neatly tucked away into a powerful single agent loop runner. This is code that is strictly typed, super easy to read, and built for long-term maintainability. Which really leaves us with this final thought. We are witnessing a massive shift right now. The industry's top leaders aren't out there building convoluted new languages or bloated abstract frameworks anymore. They are stripping things all the way back to native, clean code. So as AI frameworks increasingly rely on native language features over custom abstractions, is mastering modern Python, really understanding decorators, data classes, and dunder methods, the single most important skill for an AI developer today? I highly encourage you to open up your IDE, play around with these native Python features, and just see the elegance for yourself. Thanks so much for joining me on this explainer, and I'll catch you next time.